Welcome to Math 1 today, everybody. So today we are looking at lesson 5 in your book. We're only looking at the very first part of it. So we're looking at problems 1 through 3 and the jump start. So don't be working ahead. It's not going to make a whole lot of sense otherwise, and we're just going to have to redo it. So just 1 through 3 today. It's a pretty quick, short, and easy lesson. Now, we do have a toolkit today, so that is going to take up a decent portion of our time today. And then, like I said, we're not finishing the lesson. So when we are looking at the homework problems, we're just doing the ready today. So just the ready homework problems due tomorrow. And then quiz 4 is on Friday. So we're going to have some new homework grading guidelines as well. And I will get to those when I get back. So the very first thing we're doing is that jump start. And that jump start is on page 55. And so for that jump start, you actually need that white sheet of paper. Now, some of you turned that white sheet of paper in that you got yesterday. If that was you, that's fine. Just go ahead and look at a TableMates piece of paper and see, which letters, and you can share. So which letters from number 1, so you got A through L, correspond to each of the numbers in the jump start. So for example, for the very first one, which letters had problems that dealt with what the exponent property in number 1 is? I would put down A and D. Like those are two that just stand out to me. And so there's other ones as well. There's more than one correct answer. But I want you to go ahead, take about 2 minutes, and try to make connections. So which exponent properties did you use on that white sheet and attach them? And so 2 minutes, you got time. And this is going to be paused. All right, so now that you've had time to work on it, we got A, D for the first one. 2, we got C and F. And then you can read off the rest. But what I want to kind of point out here is that, some of these letters could show up in different places. So F showed up for 2 and it showed up for number 5. So we kind of combined those exponent properties. And that will happen is you could get multiple properties in one problem. And F is a good example of that. It does show up. So it's something to consider as we continue on. Now, I'm going to be moving on and we're going to be looking at your toolkit now. So you got time now to fill it out. It's going to be paused. Once we're ready, we'll go to the next one. And then we'll go to the next one. And then the next one. All right, now that all of that is done, we're going back to your book. We're going to be on page 55 still. And what I'm going to say is at the bottom, you have problem 6 and 7. And the thing that I need you to know, one last exponent property we have, is that a to the 0 is equal to 1. So anything to the 0 power is 1. So for example, I could write this really disgusting looking problem. And if I put to the 0 power, that's just 1. I wouldn't have to do any work to get that answer. It's just a fact. It's what it is. Now, number 7 is something else that's kind of important. So they give the example of a to the 3rd power over a to the 4th. And if there's a few ways to look at that, but if we write that out, it looks something like this. And so if we start canceling this stuff out, we end up with 1 over a. Now that's kind of important because it goes back to a different exponent property we have, which says we can just subtract. So if I get a to the 3rd minus 4, that gives me a to the negative 1. And so what that means is if you have a negative, to make it positive, you flip it. So this is really like over a 1. So if I flip it, now it looks like that. So another example of that is just going to be this. So if I have a to the negative 5, I can change that to be 1 over a to the 5th. Now, I could also have something that looks like 1 over a to the 7th and make that negative. And that just goes ahead and changes to a to the 7th. So whenever you have a negative, you just flip it to the other spot. So if it's in the denominator, it goes to the numerator and vice versa. So that's all 6 and 7 was. And we're going to move on to 56 now, or page 56. And so we're looking at this very first problem. Now, we got f of x is right here, okay? Now, f of x equals 2 to the x. If you have an x instead of an n, that means it's going to be a continuous function. And so you can see we have this curve, all the dots are connected. And what it's asking us to do is it's like, okay, so what observations do you make about Carlos's graph, especially when the x values are negative? Well, let's just think about a quick table here. So I got x and I got y. And let's put a few numbers in. So if I start, I'm going to say x is, I'll start with 2, then I'll go 1, then 0, then -1 and -2. Now, on your calculators, you can type this in. And what I really am going to caution you on is do not use the subtraction key. Make sure you use the negative key. So for these negative numbers, when I type this in, this is going to be 2. Your calculator shows that caret. You do have to put parentheses and then put -1. And what that is going to give you is going to be 0.5. Now, I'm not the biggest fan of the decimal, but I know you people and I know what we're going to put down. So if we do that again, I go 2 raised up to the -2. And just to show how I would write that out is I would just be writing 2, the caret, put parentheses and -2, and that gives me 0.25. Now, I just told you that if we have anything to the 0 power, it's just 1. So when x is 0, this becomes 1. And if we keep going, if I go 2 to the first, so notice I'm just taking all of these x's and plugging it in for the x up here. If I go 2 to the first, I get 2. And if I go 2 squared, I get 4. Now, the reason I have this set up is because really we can think about this. If I'm going in this direction, what am I doing? I'm really kind of just dividing by 2. Now, we could also say that's times 1/2. But if I'm dividing by 2, it's easier to think about right now. These numbers keep getting smaller and smaller and smaller. And the thing is, your calculator actually will stop calculating how small a number is after a certain point. But you got to realize that, you know, this negative exponent that we talked about, if I have 2 to the -2, that's the same as 1 over 2 squared. So if I take a really big number, for example, let's say I take 2 and I raise it to the -1000, that just becomes 1 over 2 raised up to the 1000 power. That's going to be a really tiny number. And I say it's going to be really tiny because this is going to be a really big number. So if you think about fractions, the bigger the denominator, the smaller that number is. So this actually never goes to 0, even though your calculator is going to say it does. So that's kind of some weird things that we're looking at here. Now, you can see that Carlita says sometimes it helps to make a table and look for patterns in the numbers. She's going to try that. Now, when we look at the table that we have, we can kind of see we're just dividing by 2, but there's going to be honestly a better way of looking at it. And to do that, we're going to go to our next page. Or, excuse me, on the bottom of your page. So number 2 has a better table. And this time, instead of using the fraction, or instead of using decimals, we're going to use fractions. So this becomes 2 to the -1, which is just 1 over 2. This 2 to the -2 becomes 1 over 2 squared. Now, 1 over 2 squared is the same as 1/4. So I'm going to drop into the graph on that one a little bit. Now, this next one, we got 2 to the -3. Now, if you type that in your calculator, you get a really small number. But really, this becomes 1/8. 2 to the -4, and that becomes 1/16. So here's the deal, folks. Sometimes when I have students doing these problems, they just go, I got positive 4, it gave me 16. That means that negative 4 is going to give me 1 over 16 because that negative is just flipping it. So that's something you can use. It's not something you need to use. But that's the kind of pattern that's going on with that. Now, again, we're going to talk more about this on Monday, but we are going to take a look now at this graph of g of x. Now, g of x is just a different function, but I really just want you to hone in right there on that 1/2. So in the last problem, it was 2 raised up to the x. And we're increasing, and just meaning as we go to the right, we shoot up into the air. So that's increasing. On this one, we got a 1/2. As we go to the right, we are going down. So we're decreasing. So that's a pretty big difference. And we can actually point that out for our similarities and differences. So one of our differences is that f of x is increasing and g of x is decreasing. Notice that g of x does not have a negative number attached to it. It has a fraction. And if you think about that, it's saying like you had 100% of something, and now I only have 50% because that 1/2 represents 0.5. So that's just something that's kind of unique to exponential functions is we have exponential growth and we have exponential decay. Now, the other thing I want to do is we're going to make a quick table for this. And I'm just going to actually pull the numbers that I can off of this. So if I look over here, the coordinates right here are 3, 8, are negative 3, 8. So I'm going to put that down, negative 3, 8. Now I can read another point, that's going to be negative 2, 4. I read another point, that's going to be negative 1 and positive 2. And then we got 0, we got 1. So if you're looking at these points, they really start looking exactly like they did yesterday. Or, sorry, not yesterday, like they did in the previous problem. So it looks like we're making a connection, but our numbers are getting flipped. And so that is actually the part that I'm going to leave you at. And so we should be a little curious about what the heck's actually going on at this point. But that is all you need to know for today. So for your homework, you now have class time to finish the ready. And I will throw this up here because I want to help you with one of these. Now, yesterday we did a few, and we only did the ones that were squared. Today we're going to do one that is cubed. So I'm just going to choose number 7 here because that's a pretty big number to deal with. And when I see number 7, I think, okay, what numbers multiply to make 160? The ones that pop in my head are going to be 16 times 10. So, so far I haven't really done anything different, but then I'm going to break it down some more. So 16 breaks down to 4 times 4, and 10 breaks down to 2 times 5. I'm going to break it down one more time. So I get 2 times 2, that's one of these 4s. I get another 2 times 2, second 4, third 2, or just another 2, and then the 5 drops in. And so we got all of that. Now this is the difference. This 5 is like a key. What this is telling me is I need 5 of the same number for it to come out as 1. And I got 1, 2, 3, 4, 5 2s. So all of these 2s go out in front. I write my radical again, and then I put the 5 in. Because all these 2s came out, the only thing that was left was a 5. So that is how you do these radical equation or expressions when it is not a 2. So like number 6 has a 2 there, we just don't write it out. But that's how that works. So you have the remaining time to work. Have a nice day and be ready for that quiz tomorrow.